attended a philosophy seminar. Jessica Moss from New York University gave a talk about the way she looks at knowledge from an Aristotelian perspective. And she was talking about discrimination as sort of the engine of knowledge. So the ability to distinguish between things drives knowledge. Now, that in itself, I guess you could say that that's at least a good start. I mean, if you just think at how AI started, or how the big breakthrough in AI started with ImageNet, it was the ability to distinguish between cats and dogs. So distinguishing between things and concepts and things along those lines certainly is a foundation of knowledge and intelligence. Now, some of the pushbacks that I'd have here, or discussion, maybe pushback is the wrong word. First, I think if we take the AI, world, and I come from that perspective. So this is me talking from an AI point of view about a philosophy, about the philosophy of truth and knowledge, which is very important. I think particularly now these concepts are being discussed a lot also in the AI community, particularly along the concept of truth. For example, XAI claims to be maximum truth seeking, versus other AIs are more politically driven. Woke AI, for example, like OpenAI and Google and Anthropic, they have their own views of reality, and they don't necessarily care about what's true. They want to proliferate what they think is important. So political views and things like that. So those are important questions. What is knowledge? What is truth? That's why I think this lecture by Jessica Moss was very interesting. Now I want to say a few things about discrimination in the philosophical term means the ability to distinguish between this or that. So this is left and this is right. This is green and this is blue and things like that. And the question comes up: okay, how do we, if you follow this argument, more discrimination means more knowledge. So how do you then not end up in a Wittgensteinian arms race of words and discrimination and definitions? And I think the answer is explanation. I think, I really like David Deutsch's approach to Popperian philosophy, and I think it fits well into this conversation. Like you can distinguish between things. I think that's fine. You can even put that as a foundation for knowledge. But what you need is explanation. So in other words, if you can explain two different things, if you can explain the difference between winter and summer, and do that in a hard to vary way, which is how David Deutsch defines knowledge, then I think it sticks, because then it's not just random pedantry, it's actually useful knowledge. If you can explain why spring is different than winter, and if you can explain why red is different than blue, then the actual discrimination itself is not even that important. What's more important is the explanation. And applied to AI, I think it's the same thing. Like we don't need to necessarily lose too much ink or sleep or energy in determining what is a woman, or whether illegal immigrants are illegal or whatever. I think it's much more important to explain what's the difference between a person that is a citizen and that isn't, and then go from there and define what does it actually mean for a country to have citizens that are documented versus illegal, and things like that, and then you can draw our own conclusions. So I think explanation is at the core of knowledge, because otherwise it is just academic pedantries or pedantry or whatever you want, Wittgensteinian arms race, going back to Wittgenstein's philosophical treatise of language, and how language can end up in a nonsensical sort of loop of definitions with no meaning. I think the explanation is key, and I think that's where the AIs, particularly the foundation model AIs, should be working towards. And I think that's the way I see, or that's the way we are going to evaluate artificial intelligence going forward. It's on their ability to discriminate. So in order, to say, okay, it's this versus that, but also to explain why that is the case. Now, this is fundamentally different, of course, from real world AI. We don't necessarily need the ability to explain why a Tesla is driving on a particular road and turning left or right. I think that's not so important. I think this approach towards what's called mechanistic AI, it's okay for debugging, but it's not necessarily important for the AI itself. I think the AI itself, as long as it does the right thing, it's fine. I think it's much more important when it comes to knowledge creation, because as we're going into a higher energy world where we have more access to energy, if we go to space, we need to have a sort of infinite demand for intelligence to make that work. And I think that's going to happen. I think intelligence is the kind of subject that has infinite demand because it creates its own problem. And to use Jessica Moss's nomenclature, she says that knowledge is sort of uncovering the thing out of obscurity, and the more we know, the more obscurity we also have, the more things there are to uncover. So this is in line. In AI, we have the concept of epistemic uncertainty and aleatoric uncertainty. And I think those two concepts actually converge, because aleatoric, in essence, could also just mean we don't have enough knowledge or it's still in obscurity, versus the epistemic uncertainty is where it's gotten out of the obscurity, to use Jessica Moss's nomenclature. And now we just have to sort of find it. We have to, think or iterate, find the essence. But we could also expand our epistemic uncertainty, if you will, by finding better solutions to aleatoric uncertainty. What I mean with that is, for example, when Max Planck discovered quantum physics, or the first steps that then led to quantum physics, we kind of went from aleatoric to epistemic, right? Because we couldn't explain things, and now all of a sudden we can. We have more knowledge, we have more understanding of nature, but that increases also the questions of epistemic. So in a sense, I think what this concept of infinite demand of intelligence means is that we are on the one hand solving our epistemic uncertainty with better models and more compute, but on the other hand also increasing or reducing aleatoric uncertainty by increasing epistemic uncertainty. So again, that means that we're entering new paths, we're stepping into new territory of knowledge, we're discovering new knowledge, creating a lot more questions around that new knowledge, and therefore solving or asking for a lot more problems to be solved. And then this can also be, for example, on a more simple terms. Let's say if we have we have no idea how to make lithium-ion batteries. We don't know how to make batteries, and then we learn how to make batteries, and at some point we discover that lithium is the best way to store energy because it's the smallest element that can store energy efficiently. And then we discover lithium-ion batteries, so now we have less aleatoric uncertainty about batteries, but a lot more epistemic uncertainty. Now we need to figure out a way to better, maybe to better dope lithium-ion batteries and things like that. So the more we know, the more resources we create, the more epistemic uncertainty we create, and the more the more intelligence we demand. Now, again, I think the ideal foundation model, or the company that will win the race of AI as far as foundation models are concerned, is the one that will work on discovering or reducing epistemic uncertainty through explanations. That's important. And the explanations, they have to be, of course, founded in reasoning. And then I think if you follow that path, you will eventually end up closer to the truth, or you will be more truth-seeking, and therefore you will have more value. And that's the key. It will be more valuable for humans, or at least within the cognitive context of humans, being more truth-seeking being better in explanatory discrimination, in other words, explaining why this is not that and why that is not this, that will have the most value for humans. Thank you.